Welcome back to Daily Maths Concepts. Today we'll be solving simultaneous equations, and we're just going to be focusing on two methods. One, the elimination method, and number two, the substitution method. We're going to see alright, so I'm just going to quickly state why is it that they call it simultaneous equation and stuff like that. As you can see in this, we have two unknowns, right? And that is the reason why we have we have exactly two situations with the same two unknowns to solve. If we only have one situation with two unknowns, then we could have as many answers as we could come up with. But when we have two unknowns with two different cases, and the unknowns should be the same values, then we're going to have definite answers for these. And so we're solving them simultaneously, which means that we're going to have to find a way to do them together, and then at the end of the day come out with one variable first and then use that to find the next variable. So basically what we're going to do now is to employ the elimination method. In the elimination method, my aim is to create two more equations. We don't have to, because there are many ways to do this. I'm just going to say that I'm going to create two more equations from these, and then from there move on. We don't have to create two more. Sometimes we could create one more. Like right now I could create one more, but I'm just going to develop just a standard thing so people can remember. I'm going to focus on the variable that I want to eliminate. For example, I want to eliminate the y variables now. So if I'm going to eliminate the y variables, so let me pick on them. Here we have the y variables, right? If I'm going to eliminate the y variable, then it means then I'm going to be focusing on the coefficients of the y variable. At this time, it's up to me if I want to focus on the signs with them, because it doesn't matter at this stage. So I'm not going to trouble the signs. I'm just going to use the numbers, which is 5 and 3. All right, so 3 is in equation 1. I'm going to use it to multiply by equation 2. The 5 is in equation 2. I'm going to use it to multiply by equation 1. As I said to you, at this time, I'm not too concerned about whether this is negative or positive, because the main thing, when you multiply an equation throughout by the same thing, it really changes nothing. All right. So the aim is that we're going to get back the same two numbers at the end of doing the multiplication, and then we'll decide what we're going to do. Let us go through this quickly. 5 times 2, that's going to give us 10x. 5 times 3 plus 15y, which is equal to 5 8, that's 40. This is my equation 3. Equation 4, 3 times 4, that's 12x. 3 times negative 5, that's negative 15y, which is equal to negative 18. And this is equation 4. So as you can see, I pick these, I interchange them. This goes up there, that comes down here, and then I multiply throughout. Here it is now. I'm seeing a positive 15 and a negative 15. The beauty about you eliminating is that when you are eliminating, you should just be mindful of the fact that the variable you pick on, you're going to get back the same numbers. So you would have only two options after that. Is either you're going to add for them to zero appear out, or you're going to subtract. Well, you would see right now that I have a negative and a positive 15. If I add them together, then they would have been eliminated. So I'm going to add. So sometimes you just write wherever that I want to add equation. I want to add equation 3 and 4. I want to add them together. So in this case, I'm talking about 10x plus 12x. When I add these two, I'll get a 0. This plus this, when we add 40 plus a negative 18, then that's what we have, all right? As you say this, when I add these, this is 0, so I don't need to write it. This becomes 22x, which is now equal to 22. Then I divide both sides by 22. Then x is equal to 1. So here it is, I'll have part of my solution. X is now equal to 1. Because x is equal to 1, I can now use back this value in any one of my 4 equations. So let me take this off right here. X is equal to 1. So let's just look at it. Now I'm going to write, since x is equal to 1, I intend to substitute, yes, I'm going to substitute 1 for x. And I could do that in any one of the equations. I'm just going to pick equation 1. So I'm going to do it in. So here is equation 1, 2x plus 3y, which is equal to 8. Alright, now remember that x is equal to 1, therefore 2 times x will now be 2 times 1 plus 3y, which is equal to 8. 2 plus 3y equal to 8. And then I'll subtract 2 from both sides. Then we have 3y is equal to 6. At this time, this is 3 times y. I'm going to divide both sides by 3. And as you could see, y is equal to 2. My conclusion, x is equal to 1 when y is equal to 2. The elimination method. So another example. So what I'm going to do now is that I'm going to create 2 more equations, but I'm going to pick on what I want to eliminate. Let us say I intend to eliminate the x this time. So I'm going to be focusing on these. If you don't see a number in front of a variable, then we know that it is number 1. All right, that's missing there, or a -1 depending on what we're looking at. But this is no negative is here, so this is 1. So I'm going to multiply the 1. I'm going to use it to multiply by up here and the 5 down here. As I said to you, this is not necessarily the only way it can be done, but I'm just trying to drill in an idea to keep. All right, because there are other ways we could create just a third and move on. But let us say we want to always have an idea like this going. 1 times the 1 goes up there and the 5 comes down here. Now we're going to create 2 more. 5 times x is 5x. 1 times y is y. 1 times 13 is 13. This is my third equation. 5 times x is going to give me 5x. 5 times 3, this is 15y. And this is going to give me -15. This is my fourth equation. Now at this stage, if you notice, my intention was I was focusing on eliminating the x, and that is why I get back a 5 and a 5. This time the signs are the same. Now because the signs are the same, I cannot add for this to eliminate. All right? For me to eliminate these 5, they are both positive, I need to subtract. So I'm just going to write on the side here that it is my intention to subtract equation, say, I'm subtracting equation 3 from a 4. 3 from 4, right? Which means I'm going to write equation 4 out front. So 5x minus 5x is gone. So I know that this cancels fully, all right? 5x minus 5x is gone. Well, let us say you want me to write it. 5x minus 5x, it's gone. Then I have a positive 15y minus y, which is equal to -15 minus 13. If you notice what I'm doing here, I am putting the like terms in the equation 4 first. So 5x, then what I'm doing, which is minus 5x, then positive 15, subtract y, because we said subtraction would work, then -15, subtract 13, and there it is. Now let us simplify. This is 0. This is going to land me 14y, which is now equal to -28. Then I'm going to divide both sides by 14, and then y is -2. So here it is, I have a solution just for the y variable. Y is -2. I can now substitute -2 for y, and I could do this in any one of the equations. I'm going to choose equation 1. So now I'm going to write back equation 1, 5x plus y is equal to 13. Remember, I'm going to substitute -2 wherever I see y. So this is 5x plus -2. I'm going to just put it in a bracket, which is equal to 13. Basically, this is the -2. So how do I cancel a -2? I'm going to add 2 to it and then add 2 to the other side. I'm looking at 5x is equal to 15. Divide this by 5, divide this by 5, x is equal to 3. So here it is, we have x equal to 3 and y equal to -2. Now if we want to test this back quickly to see if it works, then all we're going to do is substitute 3 for x and -2 for y. So let us just do that quickly to see if it works, all right? So I could just take off these quickly just to see if it works. All right, good. So we're going to substitute 3 for x. So this is going to be 5 times 3, and then -2. Okay, and this is going to be 3, and then this is going to be -2. So this is saying 15. This is 15 minus 2, which is 13, and this is 3 minus 6, which is negative 3. So yes, we could see that it works, right? All right, good. So that's us looking at the elimination method.